A binary search tree is a tree that has a particular structure that allows us to find the information quicker. At any level in the tree, as we look at the node, all values that are less than the value of that node will be in the left subtree, and all values that are greater than the value in that node will be in the right subtree. So as an example, if we're considering node 31, and we can look and see that nodes 19 and 7 are in fact less than 31, and so they show up in the left subtree, and nodes 59 and 43 are greater than 31 and show up in the right subtree. This relationship exists at every level in the tree. So if we look at 19 as an example, 7 is less than 19 and it shows up to the left of 19, so it's in the left subtree. And you notice that we have no values here off the right subtree. What would fit on the right subtree is a value like 25. Why? Because it is less than 31, but it is greater than 19, and therefore it would reside in the right subtree. Now let's look at how we insert nodes in a binary search tree. Basically, we're going to start with a potentially empty tree and a list of values to insert into the tree. We'll use simple integers here to get the point across, but the value can be anything as long as we can compare two values being less than or greater than or equal to one another. And so as we insert these values into the tree, we will travel to the left subtree if the value being inserted is less than the value at the root. And then we'll recursively do this for all nodes in the tree until we find a null pointer, in which case we will insert the correct node at that time. So let's look at an example. So we have the binary search tree on the left, and we would like to insert value 23 into this tree. So we first create a node for 23, and it's being pointed to by new node. So we'll call this new node. And we examine the root. And since new node's value, which is 23, is less than this particular node, which is the root and has value 31, we travel down the left subtree. We now check the node at this position, and since new node's value, once again, which is 23, is greater than the value at this particular node, which is 19, we will travel down the right subtree. We encounter a null pointer in the right subtree, and that is where we insert the new node. Let's look at another example. Let's start with an empty tree and the following list of numbers: 5, 14, 2, 8, 3, 9, and 7. And let's begin inserting these into the tree. So the tree is below this list of numbers and the tree is empty. And so the first value that we'll add is the 5. So that will become our root. And then we will add value 14. Well, 14 is greater than 5, so we'll travel down the right side. And the next value to be added is the value 2. So we always start at the root. We look at the fact that 2 is less than 5, and we add that particular node on the right side. On the left side, excuse me. We then have to insert value 8. Well, 8 is greater than 5, so we travel down the right subtree, and 8 is less than 14, so we travel to its left subtree, which we find the null pointer, and therefore we attach 8. We then go on to insert value number 3. It's less than 5, so that puts us on the left side. And it's greater than 2, so that puts us on the right, to the right of 2. We then have to insert 9. It's greater than 5. It's less than 14, so we go to the left. It's greater than 8, so the 9 goes right here. And finally, the 7. 7 is greater than 5, so we travel to the right subtree. 7 is less than 14, so we go to the left subtree, and 7 is less than 8. So we go to the left subtree of 8, which is null, and we insert the value at that point. Now let's take a look at something else. Let's take this same set of numbers and let's reorder it. We're just going to randomly reorder it. I'm going to pick 3 first, and then 7, and then 14, and then 5, followed by 2, followed by 9. And what am I missing? I'm missing the 8. And get the 5, the 14, the 2, the 8, the 3, and the 9 and 7. Okay, so let me fix this particular. Okay. So let's insert this sequence into an empty tree. So we begin, let's see, 1, 2, 3, I'm missing a number. 14, 2, there's the 8, there's the 3. Let's put the 7 right here. Okay, let's insert this sequence. So we begin with the 3, and obviously there's nothing in the tree, so it goes in the root. And then we look at the fact that 7, the next value, is greater than 3. So we insert the 7. And the 14 is greater than 3, and it's greater than 7. So we insert it there. And the 5 is greater than 3. And it is less than the 7. So 5 goes here. The 2 is less than the 3, so it goes right here. The 9 is greater than the 3. It is greater than the 7. It is less than the 14. So the 9 goes right over here on the left side of 14. And finally, the 8, greater than 3, greater than 7, less than 14, less than 9. So the 8 goes here. And so the thing that's worth seeing here is that the order in which we insert nodes matter. These are two differently shaped trees because the order in which we placed everything was different, and that gives us a different shape for the tree.